AI and autonomous systems are becoming some of the highest paying areas in tech. But the reason is not what most people think. Many assume it's just about new technology or innovation. But the real driver is how demand changes when systems become more critical and less tolerant to failure. In many parts of the world, systems are becoming more complex, more automated, and more dependent on real-time decision-making. And that shift is increasing the value of engineers who can build, maintain, and scale autonomous systems. In the next few minutes, I'll break down why AI and drone-related roles are growing faster than expected, where the highest-paying opportunities are emerging, and what actually determines who gets into these positions. Now, salary breakdown. Roles related to AI systems, computer vision, and autonomous platforms can reach well above $150,000, with many positions exceeding $200,000 depending on specialization. But these salaries are not evenly distributed. They tend to concentrate in specific areas where systems are critical and difficult to replace. This creates a pattern where a small group of engineers captures a large portion of the highest compensation. And this difference is not just about technology. It is about what these systems are responsible for. Another reason these roles command higher salaries is the level of responsibility involved. In many cases, engineers working on autonomous systems are not just writing code. They are building systems that operate with limited supervision and interact with real environments. This increases the cost of failure. And when the cost of failure increases, so does the value of the people building those systems. Now, market demand. Demand for AI and autonomous systems is expanding across multiple industries. From logistics and infrastructure to security and data systems, organizations are investing heavily in automation that can operate with minimal human intervention. This is where things start to accelerate. Companies are not just hiring engineers to build features. They are hiring engineers to build systems that can act, decide, and adapt. And that requires a different level of responsibility. And this is where the structure of demand begins to change. This shift is also changing how organizations think about efficiency. Instead of scaling teams, many companies are trying to scale systems. Autonomous systems allow a smaller number of engineers to influence larger operations. This creates a different type of leverage, and engineers who work in these environments often benefit from that leverage directly. Now, skill concentration. One of the main reasons salaries are higher in this area is the concentration of skills. Working with autonomous systems often requires knowledge of machine learning, distributed systems, real-time processing, and hardware integration. This combination is not common, and this is what creates scarcity. Not everyone can move into these roles easily, and this is where most people underestimate the barrier. It is not just learning one tool, it is understanding how multiple systems interact under real conditions. Now, competition level. Even though the number of developers continues to grow, the number of engineers capable of working in these environments remains limited. This creates a gap between general software development and specialized system work, and this gap is increasing. As more industries adopt automation, the demand for these skills grows faster than the supply. At the same time, not all experience transfers equally into this space. Engineers who have only worked on isolated features may find it harder to transition, because the focus here is not just on building components, but on understanding how entire systems behave. This creates an additional layer of filtering that is not always visible from the outside, and this is what makes entry into these roles more selective. Now, entry reality. For engineers trying to enter this space, the path is not always direct. Many roles require prior experience in systems, infrastructure, or applied machine learning. This makes entry more selective, and this is where positioning becomes critical. Engineers who move gradually toward these areas tend to have more success than those who try to jump directly into them. Now, long-term outlook. Over time, the importance of autonomous systems is likely to increase. More processes are becoming automated, and more decisions are being delegated to systems rather than individuals. This shifts how value is created inside organizations. Engineers working closer to these systems tend to be positioned near that value, and that changes how they are compensated. Now, positioning strategy. Engineers who move into these areas often build adjacent skills first. They start with back-end systems, infrastructure, or data pipelines, and then move toward more complex system interactions. They focus on understanding how systems behave under load, how decisions are made in real time, and how different components interact. This transition is not immediate, but it creates access to a different category of roles. Now, risk and resilience. One of the risks in this space is focusing too narrowly on tools rather than systems. Technologies change quickly, but the underlying principles of system design and automation remain more stable. Engineers who focus only on tools may find themselves needing to constantly adapt. Those who understand systems tend to move more consistently. Now, final verdict. AI and autonomous systems are not just another trend. They represent a shift in where decisions are made and how systems operate without direct human control. And that shift is creating a new layer of high-value roles, where fewer engineers operate, but where the impact and compensation tends to be higher.